Team. Something that's actually really tricky about learning computer science and computer science topics is that we are reusing a lot of regular English words, like the word object. You knew that word before you started this class, but now we're giving it a much more technical definition. And so a lot of computer science, you're not learning new words per se, you're learning new definitions for old words, okay? And maybe polymorphism is one counter example to that broader pattern. Actually, there's some science definitions. So maybe you do know the word polymorphism, just not in the computing context. So we can look at the definition in a computing context, the ability in programming to present the same programming interface for differing underlying forms. That's maybe not our most helpful definition. We are going to actually talk a lot about what interfaces are. Spoiler alert, they're more helpful than inheritance, which we're talking about now. And they're going to give us some of this same functionality and same benefits that inheritance is going to provide. We can look specifically at subtyping. Actually I can click on the computing page. Clicking on that computer science page gives me this, again, not that helpful definition, but again, this interface idea, we're going to come back to that. It's going to be super powerful and important. Let's talk about subtyping, and I'll go to that page. So in a programming language theory, okay, that just sounds fancier than it needs to. Subtyping or subtype polymorphism or inclusion polymorphism, okay, those other definitions are not important, is a type of polymorphism in which a subtype is a data type that is related to another data type, i.e. the supertype, by some notion of substitutability. And that's going to be the key idea that we're working with, is substitutability, meaning that some program elements, typically subroutines, functions, we're going to call those often methods, written to operate on elements of the supertype, can also operate on elements of a subtype. So remember, every object in Java can act like itself, or it can act like an object, right? Capital O object, because every class in Java extends implicitly the object class. Just like how we talked about if we had a person class and a student class, any student can act like a person, and any person can act like a capital O object. And the example we looked at with capital O object is even if our class didn't provide a toString method, we could call a toString method on it, and that was a way in which it was acting like a capital O object. Okay, let's go back to the polymorphism definition, in general, we can also sort of break it down. So poly means many, and morphism means change. And the things aren't actually really changing. When like a person object acts like a capital O object, it's not changing the underlying thing, but it is going to change like how we can treat it. And it's going to have that element of substitutability that we saw. Okay. Again, I do think it's really confusing in computer science, mainly that we just take old words and give them new definitions and pretend like we invented them, but you already have the old word in your head, and then we reuse them in different ways. So like a static method is kind of different than a static variable, and the word static already means unchanging, but in Java, that's what final means. We know there's a lot of vocab, but hang with us, and this is why it's really important to go to the help site, chat with people, and like practicing talking about computer science is super helpful too, to reinforce that vocabulary.